Okay guys, to start this section off, I've got a couple of activities that I want to do to gather some data again, but I got to do this one in class. We can't do it like on your calculator at home or anything. So the three activities here about the center, there's something really important that I want you to see here. But again, we can't really do any of this stuff until you guys are actually in class. So we're going to do this on Monday, and we'll fill in those notes. Now, this stuff you do know. Right here, I'm going to start here. A statistic, like an X bar, that's a mean of your sample, or a p hat, that's if you take your sample and count how many successes out of n and then turn it into a percent, or even a standard deviation or a maximum. Those are all calculations we do on data. Any one of those statistics is considered to be an unbiased estimator. If its sampling distribution is actually centered, like we've been doing some dot plots and stuff, if the center of the dot plot is actually over the parameter, the population number that it's estimating, okay? And so we're going to see out of these three activities, when we do them in class, we're going to see exactly how that plays out, where one of them doesn't fit this definition and the other two do, okay? So something to look forward to in class. I'm sure you guys will be riveted with that activity. Okay, so here's some book examples. I'm going to go to page 414. We're going to do number 1 and 2. All right, so I'm going to bring that into the picture here. 414, number 1 and 2. Here we go. Refer to the following setting. The manager of a grocery store records the total amount spent for each customer who makes a purchase at his store during the week. The values in that table summarize the distribution of that amount spent. So he got a bunch of values from a bunch of customers. Did it say how many? I don't think it said how many. Oh, it says right here. 749 customers were in there. The average they spent was $29.85. There's a standard deviation that goes with that number. That's the average amount that each one of the values is away from that mean. There's the minimum was 20 cents. The maximum is $153. Who's spending 20 cents at the grocery store? What is that? Okay, the maximum is $153.73. Then we got the 5-number summary in between. Here's a question. To investigate, if the sample median is an unbiased estimator, okay, the median is right here. The median of this population is $22.96. If we're going to investigate if the sample median, this is the population median, the sample median is an unbiased estimator of the population median, 1,000 SRSs of size 10. Now look, the population's 749, and we're just taking 10 at a time, and we want to look at what that sampling distribution looks like. The sample median for each of these samples is recorded on this dot plot here. The mean of the simulated sampling distribution is indicated by this orange line segment. Does the sample median appear to be an unbiased estimator? Well, if it is, then it should be centered over the population parameter. The population median is $22.96. All of these, I mean, you don't even see dots. There's one dot, but the rest of these dots are so close to each other it looks like a histogram. But they gave us the mean of this histogram as this orange thing, and it's right there. It's definitely just below 25. Now the median is 22.96, so basically 23. Does it look like this orange line is over 23? It does. So if the center of this sampling distribution is right on the parameter, then my answer is yeah, that's an unbiased estimator. So for number 1, it says, is it an unbiased estimator? I'm going to say yes, because the mean, that's the orange line, right? We just saw that one visually, is over the median, which equals 22.96. Since it's centered where it's supposed to be centered, then we'll say yes, we call that thing an unbiased estimator. That may not mean much to you right now, so just stick with me. That it's going to make a little more sense as we get through a couple more sections, okay? Let's do number 2, and I'm going to find out something that's not an unbiased estimator, okay? Spoiler alert. Is the minimum unbiased? To investigate the sample minimum, to see if that's an unbiased estimator, 1,000 SRSs of size 10. So once again, the population is 749, but we're taking samples of size 10, and we're simulating. So this isn't really the sampling distribution. It's a simulation to kind of help us think about what the sampling distribution would look like. Okay, I hope that makes sense. But every dot on here, like all these dots, are the result of a sample of size 10 And what we got is a minimum from that group. So we're not taking averages. We're not looking at medians. This time, these are all minimums. All right. The sample minimum for each of these samples was recorded on the dot plot. The mean of this dot plot, the average of all these minimums, is indicated by an orange line. Does the sample minimum appear to be an unbiased estimator? Well, look at the orange line. That lands at around 6. And what is the actual population minimum? We talked about it. It's 20 cents, 0.20. And this orange line is way up here around 6. Because when we take different samples, they're not all going to contain the actual minimum, right? They're all going to have things that are higher. So this one's going to be off because of the way we're doing things. So my answer here is no, that's not a unbiased estimator, because the mean, which is an orange line, is not over the minimum of the population, which, let me look again, it was 20 cents. This mean was over the mean of the minimums. That was over like 6, basically. So it's not even close. Okay? Let's go to the second page. And from these 3 activities that we do, I don't think I'm really giving anything away here, even though we didn't do the activities. It's clear that all 3 activities, the spread, you guys have already seen this when we counted all the coins. Okay? The spread of the distribution becomes smaller as the sample size increases. The spread, the standard deviation type measurements of the sampling distribution, they'll get smaller when the sample size increases. Okay, so in general, we'll be measuring the spread basically for just about the rest of this class with a standard deviation. Now you can also measure it with a range, which we've said from the very beginning is kind of stupid, and an IQR, which is helpful sometimes, but we're going to focus pretty heavy on this standard deviation. So as n increases in general, a standard deviation decreases in general. Okay, I'm going to go back to the book and do a couple problems, 5 and 6. Get you out of here pretty quickly. Because we didn't do the activity, I'm going to hold off on the homework for tonight. So no homework for the weekend for you. Hey, there's something. More about medians. Refer to exercise 1. What do you think would happen to the sampling distribution that we looked at on the other page? Or at least we looked at simulations that kind of model the sampling distribution. What would happen to it if the sample median, if the size was 50 instead? If the sample size was 50 instead of what we did. Now, they took 1,000 of these things, but that's not what they're talking about. Every time they took one of these, the sample size was 10. If they took 1,000 of them and the sample size was 50, don't we know that this would do this? Like we saw that with the coins. If the sample size goes up, the spread of the sampling distribution goes down. So I'm going to say since n equals 50 is much larger, the standard deviation will definitely be smaller. I don't need to take a look at a bunch of them. I know that's going to happen. So we're learning about some tendencies about these sampling distributions. Okay, bigger sample size, standard deviation gets smaller. You saw it on the dot plot with the coins the other day. Let's see, what else do we got going on with number 4 here? It doesn't have a part B. This says 5, A and B. Here we go. What would happen to the sampling distribution if the sample mean was 50 instead? Well, that's the one I just read. Oh, I see what's going on. This is wrong. That should have been number 5, and this should be number 6. I'm killing it this week, guys. I'm telling you. I'll be accepting my award on Monday for my teaching job this week. More about minimums. Refer to the exercise 2, where we saw the minimums in the orange line. What would happen to the sampling distribution if the sample size were 50 instead? And then it says, what's the practical consequence of this change? Okay, we can address that. It set it up here, too. What's the practical consequence of this change? Okay, for part A, I'm going to say the same thing. Since n equals 50, the standard deviation decreases. Okay, and so that's a good thing for us, as we talked about. If the standard deviation gets smaller, then when I take my one sample, which is what we normally do, I'm more guaranteed to be close. I'm going to keep saying that. I know I've said it a few times. But part B for these, both of them, it says, what's the practical... Let me read it again. Let me read it one more time. It says, what's the practical consequence of this change in sample size, the practical consequence, you actually have to take and measure, however you're counting these things, more people in your sample. I mean, that's work, right? That's more work. And so, yeah, n equals 50 is better, but there's more work to be done here, so you actually have to do more work. And here, I'm just going to say same thing. I'm not going to change my answer for that. Okay, last thing for us for the week. No homework. Just think through this for a second. Random question. If you're going to take one sample instead of 1,000 of them, and you're going to make a big decision about an unknown parameter. So in this case, what actually happens is you don't actually know the parameter. Now, I'm doing a whole bunch of examples where we do know the parameter so that you can get a feel for how things change when it's biased and unbiased and when the sample size is bigger or smaller. But here I'm saying we don't know the unknown parameter. If we're going to use that one sample, which of the following characteristics of a distribution would you prefer? A lot of bias and a lot of spread, a lot of bias and low spread, low bias and a lot of spread, or low bias and low variability. Which of those scenarios do you want to try and create so that when you take your one sample, you can feel pretty confident in your answer? And that's this one right here. I can usually get low bias with an SRS, right? Or, I mean, that's the sampling method, but you saw earlier that minimums, they don't really work. So you got to make sure you're doing something like a mean or a median. And then low variability, how do we accomplish that? We accomplish that with a larger sample size. Isn't that what we've learned here? So we didn't get to do the whole lesson plan here today, guys, because I've got some stuff I want to get some numbers, and I do want you to see why one of these doesn't really work. And so I don't feel comfortable giving you homework. I think you're just going to have to live with a no homework kind of a weekend here. And you guys enjoy your day.